Well, ladies and gentlemen, hello again, and welcome to another Reflected Reality Simulations video. My name is Graham, this is X-Plane 11 and the Britten-Norman Islander by TorqueSim. We're at Lee-on-Solent Airport on the south coast of the UK, halfway between Southampton and Portsmouth, and Lee-on-Solent is where the final assembly of the Islander currently happens. The Islander has been in production for a great number of years, a very successful product. It occupies a very niche market for short takeoff and landing commuters, very popular in the Caribbean and used extensively around the world. About 20 years ago, I spent a lot of time in Microsoft Flight Simulator flying a lovely freeware model of the Islander, and this TorqueSim model has brought all those memories flooding back. It is beautifully detailed on the outside, the 3D modelling is exquisite, and it flies really nicely. It flies exactly how I imagine an Islander would fly. I've not had a chance to fly an Islander for real, although I'd dearly love to. The closest I got was a Piper Seneca 2, which has got similar performance to an Islander. It's got smaller engines, but it is turbocharged, performs a little bit better, but needs a lot more runway. The Islander is essentially a big Super Cub. So TorqueSim have given us a very detailed model. What I aim to do is fly the aircraft around for about an hour, looking at the features on the aircraft and exploring how to fly an ILS approach with the aircraft, and then do some visual circuits. I'll split the video up into 3 parts. So let's get it set up. We can remove the chocks, the cones, the pitot cover and the inlet covers. I'll leave all the settings on here. We'll put 2 pilots and we'll put 7 passengers on. If I leave the back row with 1 passenger out, it means I can fill the fuel tanks and keep the aircraft below the maximum landing weight of 6,300 pounds. You can go up to 6.6 for takeoff, but 6.3 for landing. It also helps keep the trim more in the middle. When we get inside the Islander, the first thing you'll note is that the pilot's door is right next to the left-hand engine, and if we got that wrong, it would be not a very pleasant day. So there's a safety system we have to check. If I put the battery power on and try one of the mags on the left engine, you hear the warning. That's actually the stall warner, but what it's telling me in this case is the fact that the door is open with the mags on. If I do the check again, you see that I don't get the warning. Now in the real thing, with the mags on, the door is actually locked. This is a release lever here to release the interlock for emergencies. But that's not modelled in the simulator. It's a very straightforward aircraft to set up. We're going to go top to bottom and left to right. So first thing is we've got the rudder trim, that's set to neutral, that's fine. And then we've got the fuel selectors. Now these have been left in left engine, left tank, right engine, right tank, and that's fine. What we can do on the first flight of the day is set the left engine to the right tank and the right engine to left tank. That way that we verify that the crossfeed actually works before we get airborne. On the overhead panel, the vent motor, the heater selected off, the mags are off, the fuel pumps are off, we've got sufficient fuel for the trip. On the main panel, all the switches are off. The propeller is forward, the mixture and the throttle's off, parking brake set, carb heat's cold, and all the circuit breakers are in. With that, we'll put the battery power on and we'll start bringing the aircraft to life. I'll put the nav lights on, the cabin lights and the passenger notices on. That's the notices over here. And you'll see that we've got a fair crowd on the aircraft today. So it's very easy to start the aircraft up. We need to make sure the avionics are selected off to start. If we need to get a clearance before start, bring the avionics on, call for the clearance, and then switch the avionics back off again. One of the oddities of the Islander is this external supply switch here. That actually isolates the starter switch. Let me just bring the lights up as well. In order to start the engines, I've got to put the external supply switch on. So I tie that in with a beacon. Beacon on, supply switch on. I'll set the throttle slightly open. I'll put the mixture full rich, and then we'll switch the pumps on. We'll start the right engine first. We'll start on the number 1 mag only. So that's on. I've got throttle, mixture, fuel selectors, fuel pumps and mags, and the propeller area is clear. Starting the right engine. it fires, oil pressure's in the green, I've got 1000 RPM, second mag comes on. As simple as that. Left engine, same thing. Number 1 mag on, starter, it's running, oil pressure's in the green, 1000 RPM, second mag on. Dead straightforward. Before we do anything else, I need to make sure that I actually am running properly on both mags. We check that by turning each mag off, make sure we get a slight drop but the engine doesn't stop. So there's drop, no stop, drop and no stop. We've got control of the left mags, and on the right hand side same thing, drop, no stop, drop, no stop. The mags are good. I'll put the cabin vent blower on, fuel pumps off, and I'll return the fuel tanks to the normal configuration. So we can see with that we are draining the battery. The battery drain is about -10 amps and we've got 24 volts on there. So I need to put the generators online. If I look at the current for the left generator, there's nothing there, so I need to select it on. The warning light goes out and it's charging 10 amps and it's gone from 24 volts to about 28. That's fine. If I look back at the battery, you see that we are charging. Back to the left generator, 10 amps at the moment. If I put the right one on, it drops down to 5. Voltage is still good. We'll check the right gen as well. All is good. So we've basically checked that we've got both generators operating successfully. Having done that, I'll put the avionics on and I'll remember to switch off that external supply switch that isolates the starter. So the switch panel is set for after start. Avionics to sort out, I'll put the transponder to alt because we're going to taxi in a second, and I've got a flight plan that I preloaded just to save a little bit of time. The compass system on the Islander is fairly interesting. We've got a compass that is slaved to a magnetic detector essentially. With it in slave mode, I can slew the gyro slightly, both ways, and make sure it returns to center, which is perfect. I can also go into free mode and move it just like I would a conventional gyro. So I want to make sure that we go back to slaving. We should be roughly pointing south here. There's south and south on the compass. On the other side, I've got a normal mechanical gyro, so I need to set that myself. Make sure that I set it to south. There we go. And that is basically that. It's set up and ready to go. We've got the fuel tank configuration correct, mags are on, and the switch panel is set correctly. We call air traffic, ask for permission to taxi, check we're clear on the left hand side, release the brakes, and off we go. I'll do a very quick brake pressure check, and then we'll taxi out. So before we enter the runway, I'll do an engine run-up check. We'll check the mags at 2100 RPM to make sure they are behaving correctly, but we only really need to do that on the first flight of the day. And what actually happens in most commercial operations is as the aircraft is being prepped ready for the day's flying, they do the engine run-up check at that point, so they don't have to do it with passengers on board. All you need to do with passengers is a quick check of the mags to make sure that you've got both mags running. What some people forget is the default state on the mag is to be live. When you switch it off, you're actually grounding the mag to the aircraft ground. So if the wire to the mag control breaks, the mag will default to live. So you need to make sure that you've got control of both mags. If the mag timing slips, you'll have very rough running on the engine, so you've got to be able to select it off. But we'll do the full run-up on this flight. CHTs are still a little bit on the low side, but the oil temperature has come up, so we're good to do the run-up when we get to the holding point. Again, if this wasn't the first flight of the day, I could be doing the propeller checks on the taxi out as well, but we'll leave that until we've done the run-ups. Very straightforward aircraft to operate, the Islander. Once you've done a few flights with it, it becomes second nature. We don't need the full runway at Lee-on-Solent. The Islander is very capable of using a short airfield. 450-500 meters should be enough for most cases, as long as it's not too hot or too high. A useful tip in the sim is if you can see some of the paved area down the left hand side here, that's a good indication of where the left hand main gear is as well. So rather than enter the runway, what I'll do is I'll slow down, I'll point the aircraft roughly in the direction of where the wind will be coming from, come to a halt and set the parking brake. Parking brake set, and I'll reset 1000 RPM. So to do the run up check, we're going to bring the RPM up to 2100, check the mags and then check the gyro suction. Now it's a constant speed propeller on the engine on this aircraft. The propeller levers are full forward, which means the RPM is trying to get to 2700. It's just the engines aren't providing enough power to get it there. So as I bring the throttle lever forward, you'll note that the RPM increases and the manifold comes up. I'm going to go to 2100 RPM, which we've got, and I'll check the mags again. We're looking for a slight drop on each mag. There's a slight drop, I think it's less than 150. Slight drop on the other side, and they were both providing about the same drop, so less than 150 total drop and less than 50 between. I'll do the same on the right hand side. So slight drop, equal performance on the mags. So mags are fine. Gyro suction, the gyro suction here, that's providing air to drive the instruments. We'll also check the carburetor heat down here. I've got a keystroke for that. When we make the carb heat hot, I'm expecting a slight drop, and cold, a slight recovery. That's fine. All the other T's and P's at the higher power setting are correct. The carb heat indication here, the carb temperature, don't worry about that in X-Plane. It's a laminar research oddity. They never seem to be able to make that work right. I'll bring the power back to 1500 RPM. And at 1500 RPM we're going to cycle the propeller a few times, or the propellers a few times. The propeller governor, which controls the speed, is oil driven, and if the aircraft's been sitting overnight, the oil could be cold and heavy, so we need to cycle the engine propellers to make sure they can feather. I'll do it individually. So we've got good feather, don't let it go below 1500. As that one's recovering, we'll do the right hand side. It's recovering. I'll do it again separately. You note the mouse cursor changes, that's individual, and when it's the arrows it's both. So the final check, we'll do them both together. Both drop off, not really below 1200, and it comes back to 1500 we had before, so the propellers are behaving themselves. Last thing we check is we'll come back to idle. I'll bring the power all the way back, the throttle all the way back, and make sure the engine is capable of idling. If the engine was still really cold, or the carburetor wasn't performing correctly, the engine may stop rather than idle. But this one's doing fine, back to 1000 RPM, and all temperatures are fine. CHTs will be ready to go by the time we enter the runway. So as I said, the Islander is a very simple aircraft. With that in mind, we can use a fairly simple checklist. I'll put the fuel pumps on, and I'll set the trim, and then we'll run through the checks. So I tend to use about plus 2.5 degrees initially on this aircraft. The checks, we'd call it hatches and harnesses, or doors and seat belts. Well, the doors, there's a door warning light here, it's out, we check all the lights, it works as expected, that's fine. Seat belts, we've got the seatbelt sign switched on, that's all we need to worry about in the Islander. Flight instruments are all set. I suppose we could set the runway heading here just for information. There's around about 225, and I'll put the heading bug to 225 as well. So flight instruments are set correctly, it's using GPS. Engine indications are looking reasonable. We've got good fuel pressure with the pumps on, CHTs are coming up. Throttle friction, not a thing in the sim, but the trim is set. The mixtures are full rich. The mags are running on both. The prop is fully fine. There's no primer on this aircraft. Flaps are to take off. Fuel pumps on. Fuel selection and quantity is good. Carb heat is cold, and final check is the flight controls. Now the thing to note is how much movement you get on the flight control on any real aircraft. The flight controls move a huge amount, and when you translate that to a desktop joystick that's moving maybe 3 or 4 inches in each direction, the finesse that you have in a real aircraft is a lot better than you have in a simulator. But we've been through all the checks and the aircraft is more or less ready to line up. So let's taxi towards the runway. So takeoff is going to be full power. We're going to rotate just about 60 knots or so to climb out no lower than 65 to 70 initially. 65 is the blue line speed here, that's the minimum control speed airborne. We don't want to be below that. As we enter the runway, pitot and stall warning heaters on, left and right landing lights on, all the other switches checked, and the runway is clear. So I'm initially going to pitch to hold 65 to 70. Once we get above 200 feet I can consider retracting the flaps, and once I'm above the relevant obstacles and have to accelerate slightly, I can lower the nose and bring the propeller RPM back. Excellent, so off we go. $2,700 RPM, T's and P's in the green. We have 40 knots, it's cross-checked. 50, 55, rotate. So climbing away, pitching for around about 12 to 15 degrees. Adjust the pitch trim as required. Make sure the speed doesn't go below 65 knots. I'll just lower the nose ever so slightly. And it's as simple as that with the Islander. As I said, it's just like a big Super Cub. Above 200 feet I'm going to retract the flaps, and as we bring the flaps in you'll notice a little bit of sink, so I'll increase the pitch attitude ever so slightly to offset that. At this weight around about 15 degrees should work, but that's prototypical, that's what the real thing does. Now the flaps are in, 75 to 80 miles an hour is fine. But here we are at 500 feet out over the water, there's no obstacles, so I'm going to lower the nose to about 10 degrees, and with the propeller key binding I've got, I'll just bring the RPM back to about 2,500. I'll retrim again, and continue climbing. 10 degrees at my viewpoint is roughly the instrument panel on the horizon. Clear on the left side, so I'll start a gentle left turn. And this is what the Islander is about, it's all about simple stick and rudder flying. So there's 1,000 feet. What I'm going to do is lower the nose a little bit more. We could continue climbing at 95, but we're not pressurised, so I'm going to reduce the rate of climb and actually allow ourselves to make some progress towards the destination. So 500 feet a minute should work out quite nicely. Above 1,000 feet, I'll switch the fuel pumps off and check the pressure remains in the green arc there, that's fine. 500 feet a minute, we should be able to roughly see where we're going out the front of the aircraft. We've got a rudder trim, so I can use that with my key binding as well. And I'm very happy the developers chose not to disable the aileron trim. Although the Islander isn't fitted with an aileron trim, having it available as a key binding is very useful because it's a lot harder to fly with a centre sprung joystick than it is with a yoke where you can add just a little bit of pressure. So climbing away, that's the Isle of Wight on the right hand side, and on the left hand side you've got Southampton Water behind us and routing down the Solent. So what I want to do is to put the Autopilot in. The Autopilot is a slightly customised version of the Laminar Research default Autopilot. One of the annoyances with Laminar Research Autopilot is the rather rough engagement in pitch mode. That happens because it brings the Autopilot in before it centralises the flight directors. It's been reported to TorqueSim, and I believe they're going to, if Laminar don't fix it by the end of 1.5 final, then TorqueSim will implement a fix. I've actually written a very short Lua script, Fly with Lua, that gives me a smooth autopilot engagement. What I do is I push and hold the button on the joystick, and it brings me roll vertical speed, but only in the hidden flight director mode, so it tracks my VS, and then as I let the joystick button go, it latches onto that VS. So like control wheel steering really. I've got VS 500 feet per minute. One of the oddities of the autopilot is that it's got 3000 uninitiated, but it won't stop there, it'll blast right through it. I've got to push the arm button till I get Alt Arm, and now it will stop at 3000. Finally, I can bring the heading bug round onto maybe about 130. I'll put it into heading, and we'll let the aircraft climb up to 3000. So the autopilot is capable of flying the aircraft quite nicely. We just need to be aware that, as with lots of things in the simulator, some compromises are necessary. This aircraft primarily is about stick and rudder flying. I'm demonstrating the autopilot to make sure that you're aware how to use it. Similarly with the instrument approach, I will do an ILS approach today, but in real life you'd do visual approaches as much as possible. It's just that sort of airplane. So looking outside, here's the Isle of Wight on the right hand side. Here's Bembridge Airport. This is where the Islander was originally built, one of the reasons for the Islander's name in the first place. There's Ryde Pier here, Southampton Water and the Solent. Over here at the west end of the Isle of Wight is the Needles. There's a rocket engine testing station there in the 1950s and 60s, and St Catherine's Point on the south coast of the Isle of Wight. There's also another airfield, Sandown, which is around about here. You can just about see it. So there's 3000 feet, propeller is 2500 RPM, and the power lever, the throttle, is still full forward. What I'm going to do is reduce the power setting and reduce the noise. So if I bring the throttle back to just below 23 inches, and then I use my keyboard shortcut to bring the RPM back to 2300, you'll see that as I reduce the RPM, the manifold pressure increases ever so slightly. 23 and 23, it's a good place to cruise at. It's not a fast aircraft at 130, 140 knots, but it's fine for the flying it does. The last thing we can do is just lean the mixture ever so slightly. You'll notice that despite the fact it's got an American engine, it's a Lycoming 0540, the EGTs are calibrated in centigrade or Celsius rather than Fahrenheit. So about 1000 Celsius is your peak EGT typically. It's at 750 just now. I'll bring the mixture back and it should peak out around about 1000. Yeah, 1000's the peak, and then I'll just push it over to the rich side again until it comes down to around about 900 or so. We don't have a fuel flow gauge in this aircraft. If we had a fuel flow gauge, it would be a lot easier to lean it, but to be honest, it's not really that sort of airplane. Anything between 700 and 900 at normal cruise settings is fine. So let's turn the aircraft around on the heading bug, and we'll take a look at nav mode on the autopilot. I really like the look of the aircraft. I think they've really captured the feel of the Islander. The 3D modelling is outstanding. Let me bring the GPS up separately. What I'm going to do is go into my flight plan page. I'll select RUDMO and do direct. So there's direct RUDMO. And I'll put the autopilot into the nav mode. So it's now nav 3000 RUDMO. The autopilot system predates the GNS 530 by a few years. The autopilot wasn't really designed with the 530 in mind. So in real life, the 530's got some special settings to make it work with the KFC 225, and we'll explore that in the next video. Obviously with the Laminar Research 530 you don't have that. But what's important to note is in nav mode with GPS on the CDI, the GPS is steering the autopilot directly. It knows about the direct track, it knows about the cross track, and it doesn't care what's set on the HSI here. that doesn't affect how it captures the course. Now on some aircraft that will be a problem, you need to have the HSI set correctly, but this aircraft, it's got digital mode, it reads the digital information from the GPS for nav. However, if you note the message saying set course to 345, well, we should probably do that. When I get to 345, the message disappears. It's always good practice to have that CDI bar or HSI select bar set to what the aircraft is trying to fly, because one day you'll get an aircraft that needs that. If we had an older autopilot that isn't able to read the GPS directly, it can only read the deviation bar, then you would get all sorts of lost if you didn't realign that. So it's important to keep that in mind. That should probably do it for the first video. In the next video we'll fly an ILS approach down to Southampton, do the missed approach, and then in the final video we'll continue down towards Lee-on-Solent and do a visual circuit to land. I hope you'll join me for that video, those videos. Thanks for listening, and I'll speak to you again a little bit later.